Why is squaring the circle impossible in geometry? Imagine trying to draw a perfect square that matches the size of a circle using only a compass and a straightedge. It sounds simple, but it turns out to be impossible. This puzzle has fascinated mathematicians for centuries. The reason lies deep within the nature of numbers and shapes. To understand why, let's look at the basics. The area of a circle is calculated by multiplying pi by the radius squared. Pi is a special number that relates a circle's diameter to its circumference. To make a square with the same area, you need to find a side length that equals the square root of pi times the radius. Now, here's the tricky part. Constructing that length with only a compass and straightedge means that this length must be a constructible number. Constructible numbers are lengths you can make from a unit length using a finite number of simple steps. These steps involve drawing circles and lines, and the resulting lengths are algebraic numbers. But pi is not algebraic. It is a transcendental number. That means pi is not a root of any polynomial with rational coefficients. Ferdinand von Lindemann proved this in 1882. Because pi is transcendental, its square root is also transcendental. This means you cannot construct the length that equals the square root of pi with just a compass and straightedge. Since this length is essential for creating the square with the same area as the circle, it makes the task impossible under those rules. This limitation is specific to classical geometric tools. If you use more advanced methods or tools beyond compass and straightedge, you might approximate the shape, but you cannot do it exactly. When we think about squares and other quadrilaterals, they are shapes we can easily draw because their side lengths are usually rational or algebraic numbers. But when it comes to matching a circle's area with a square, the transcendental nature of pi creates a fundamental barrier. This idea helps us understand why certain geometric problems cannot be solved with just simple tools. It also shows how the properties of numbers influence what we can and cannot draw. In real-world applications, this is why engineers and designers use approximations when working with circles and squares. They know that perfect precision is impossible, but close enough often works just fine. So, the reason squaring the circle is impossible is because the length needed involves pi, which cannot be constructed with compass and straightedge. This fact connects the world of numbers with the limits of geometric construction, reminding us of the fascinating relationship between mathematics and shapes.